solution. I'll take what you meant by a primary and a secondary standards. Okay, here you are preparing a standard solution. The standard solution is nothing but whose concentration is exactly known. That is what we call it as a standard solution. A known quantity of solute is dissolved in a known amount of solvent. That is what we called it as a standard solution. The standards are materials containing a precisely known concentration of a substance for use in quantitative analysis. Like in the preparation of hard water, you are preparing a standard EDTA solution. Yeah. To prepare a standard EDTA solution, you are taking a known quantity of solute EDTA that is dissolved in solvent to produce solution of known strength. That is what we call it as a standard solution. Okay, that standard solution usually provides a reference that can be used to determine unknown concentration or to calibrate. Say analytical instruments. So here the standard solution means not only used for titration, even it is used for the calibration of instrument. See, in the calibration of conductometry, we usually use KCl solution, that is to standardize the instruments. Okay, and that solution is actually a primary standard solution. There are two kinds of standard solution. One is a primary standard solution, the other one is a secondary standard solution. Now we'll consider what is primary standard solution. Again the same here, we are using a solute of extremely pure salt. Okay, but the content we use, it is extremely pure, that is 99.8% pure crystal should be used, 99.8% pure. Okay, that's why here it is comes first, primary. Okay, to prepare a primary standard solution, that chemical or reagent should possess some properties. The first thing is it is extremely pure. It should be extremely pure, highly stable. It should not react with any atmospheric content. I'll explain you later. I'll just take the points. It is extremely pure, highly stable. It is anhydrous in nature. It is less hygroscopic, that means it should not react with the atmospheric moisture or water. Has a very high molecular weight, can be weighed easily, should be ready to use and available, should be preferably non-toxic, should not be expensive. Okay, this is a general thing, but these around the four things are mandatory to prepare a standard solution. The salt should be extremely pure, it should be highly stable, it is anhydrous in nature, less hygroscopic, very high molecular weight, can be weighed easily, should be ready to use and available, should be preferably non-toxic, should not be expensive. Here, I'll take one by one. Here, the first thing is it should be extremely pure, which means that it should not contain any other components. Okay, chemicals of high grade purity, that is, we expect about 99.98% pure. Okay, a different grade of chemicals are available in the laboratory, but while preparing a standard solution, we have to choose a purity of 99.98% pure. So in the label only it is mentioned like the percentage of purity. So if you are preparing a solution of known strength, that is a standard solution, and if you are using a 99.98 purity of salt, then you are preparing a primary standard solution. It should be extremely pure sample. and it should be highly stable. It should not react with any atmospheric content, which means it is usually does not react easily when kept in pure form. If you keep the crystal in a pure form, it should not interact with the atmospheric content. It should be very low reactivity at a atmospheric temperature and with the atmospheric content. This is important because if the reagent reacts easily with the atmospheric content like oxygen, water, carbon dioxide, they change their property. Instead of retaining it as a particular crystal, it may become a crystal with water like a hydrated form. Okay, it is, and again, while preparing a standard solutions, what we prepared or what the amount of crystal taken, it becomes other than the actual amount is required. In such a case, we should not use that type of, or we are not consider that solution is a primary standard solution. We can never use such unstable and unreliable chemicals as a standard. The first thing is it should be pure. The second thing is it should be highly stable. And it should be anhydrous, which means that it does not contain any water molecule in its molecular structure. If it contains a water molecules, then while estimating the normality or the molarity of that particular solution, you have to consider the number of moles of waters present in that sample. Say, for example, here the given is a manganese sulfate. Okay, I'll take magnesium sulfate. Okay, see in that's what Epsom salt. The magnesium sulfate is MgSO4. Okay, and the same magnesium sulfate, if you purchase from the outsource like in the drug or in a grocery, you will get hydrated form of magnesium sulfate, MgSO4 7H2O. Both are Epsom salt. Consider if you purchase in the chemistry or the chemical laboratory, it is anhydrous form of component, that is MgSO4. Whereas if you purchase the same chemical in the store, then you get a hydrated manganese sulfate, magnesium sulfate. And if you want to prepare a solution of magnesium sulfate, okay, then their property or then the strength becomes entirely different, which is prepared from magnesium sulfate to that of hydrated magnesium sulfate. What the magnesium sulfate we used in the laboratory, it is 99.98% pure. It will not contain any other component. Whereas the magnesium sulfate we purchased from the outsource, it usually contains 7 moles of water. So that is usually available with the common vendors. Okay, it is not a standard one. Or if you prepare a solution with this magnesium sulfate, it is a primary solution, standard solution. But this is not a primary because it is not a pure one. Okay, anhydrous, and the chemical preferably should be less hygroscopic. That is, if you open that container, it should not absorb water molecules. If it is absorb water molecules, that component is a hygroscopic in nature. See, the water, if it is entered or it is combined with the content, the chemical, then the net molecular weight of that compound gets increased. And based on that, if you prepare a standard solution, calculation of standard concentration is entirely different from the previous one. See, in case of high molecular weight compound, to its similar form. So we can take an example of Epsom salt itself. If you take 1 gram of Epsom salt to fit for making a primary standard solution, and we'll take it as a salt A. Salt A is 1 gram magnesium sulfate. Then I'll prepare the same one by using salt B that contains hydrated magnesium sulfate. Okay, salt B. Is their molecular weight is same? No. The salt A, that molecular weight is 108, whereas salt B from that, if you prepare the solution, their molecular weight is 234. And you know that one molecules of salt A weight is 108 atomic mass unit, but in case of B it is not 108. It will be 108 out of its total weight of 234 atomic mass unit, because it is not just a MgSO4, it contains 7 moles of water. So the entire molecular mass of this, atomic mass of this is 234. Out of 234 we observe only 108 mass of MgSO4. Okay, so here 108 gram of salt A will give 108 gram of magnesium sulfate, but 1 gram of magnesium sulfate will give exactly the same 1 gram of magnesium sulfate in case of the net, that is a pure magnesium sulfate. If you use this component MgSO4 7H2O, okay, that is 233 gram of salt B will give 108 gram of magnesium sulfate. Therefore, for 1 gram of magnesium sulfate with 7H2O salt give, that is 108 divided by 234. That means only 0.461 gram of magnesium sulfate. Clear? See, if you prepare magnesium sulfate, you will get exact 1 gram of MgSO4 is present. But if you use the salt like this one, you are assuming that it contained 1 gram, but actual thing is it contained only 0.461 gram of magnesium sulfate. Clear? Therefore, if you by mistake make a standard out of salt B, you will actually be taking 0.641 gram of magnesium sulfate, not 1 gram. But while calculating, you are taking like it is a 1 gram. Here you are taking less quantity of magnesium sulfate if it is a hygroscopic in nature. So it will absorb water molecule that also included in the salt. So with this faulty standard estimation of magnesium sulfate or any other component, a less results than the actual concentration is appears. Therefore, it is important to note the primary standard solution. While preparing primary standard solution, it should be an anhydrous in nature and should be high molecular mass. As the molecular mass increases, the molecular mass of that component increases, so that the error will be minimized. Clear? So is it clear why it should be high pure? It should be high pure and it should not react with the atmospheric content. It should be less hygroscopic in nature. If it absorbs water, then the net content of that molecular or atomic mass unit increases. Okay, so I gave one example like magnesium sulfate. Their atomic mass unit is 108 gram. If you want to prepare a 1 gram of magnesium salts in that one solution, if you want to prepare, then if you purchase that one, if it is a highly pure in nature, then if you use a 1 gram of magnesium sulfate, that takes a 1 gram of magnesium sulfate, or in the solution we can observe 1 gram of magnesium sulfate. Or instead of taking that magnesium sulfate in the chemical laboratory, if you purchase from a common, then it usually contains 7 moles of water and you will think that it is a 108 gram of magnesium sulfate, but it's actually their atomic mass unit is not 108, it is 234 atomic mass unit. So that when you are preparing a solution, if you are dissolve 1 gram of magnesium sulfate, that shows only 0.46 gram of magnesium sulfate, not 1 gram of magnesium sulfate, because it contains 7 moles of water that also contributes while preparing the solution. And that solution is not a primary standard solution. Or the previous one you prepared, it is a primary standard solution because the content or the salt is highly pure in nature. It can be weighed easily because it is a pure, that its weight is in fact a true representative of number of moles present in its actual weight that you already observed, because magnesium sulfate with a hydrated magnesium sulfate. On one of uses of primary standard solution is to standardize a volumetric solution. That means they are used for standardization of titration of solution. It can be used for titrations of acid as well as base. Okay, say these are the some examples we normally used. The salt which is used to prepare a standard solution. In case of acid-base titration, if you want to carry a acid-base titration, that time we normally use a primary standard solution, a sodium carbonate, which is in anhydrous in nature. There is a availability of a hydrous with a water molecule, sodium carbonate, but we have to purchase sodium carbonate anhydrous sodium carbonate, potassium hydrogen phthalate, oxalic acid. For redox reaction, we normally use potassium dichromate. We are not use potassium permanganate. The potassium permanganate is also a good oxidizing agent, but we are not use potassium permanganate. We normally use potassium dichromate. It is a less reactive towards the atmospheric content. And even potassium bromate, potassium iodate, oxalic acid, arsenic acid, oxides, etc. And in the case of precipitation titration, we can observe a stable component of silver nitrate. And for complexometric metallic zinc or zinc chloride is used. Okay, these are all things about primary standard solution. Okay, the type of standard solution is a secondary standard solution. Is a substance which may be used for standardizations and whose content of the active substance has been found by comparison. It is not the actual, it is by comparison against primary standard solution. Okay, it is by comparison against primary standard solution. Secondary standard is used by standard laboratories such as companies involved in the preparation of reagents, kits, and laboratories responsible for providing quality control materials for other labs. Here we normally observe secondary standard solution. Okay. In the lab, we normally use a primary standard solution. We're not using a secondary standard solution. But even in a small scale lab, we observe the secondary. That is that they are preparing some standard solution. Based on that solutions, we'll compare the other solution, and that is what we considered as a secondary standard solution. A secondary standard is a substance which may be used for standardization whose content of active substance has been found by comparison against a primary standard. A secondary standard is used by standard laboratories such as companies involved in preparation of reagents, kits, laboratories responsible for producing quality control material for other labs. The secondary standard is used for the purpose of calibration of control material in smaller lab for analysis of unknown concentration of a substance. See, then same way in the case of primary standard solutions, we observe certain properties. The same way we'll observe certain properties that should possess by a secondary standard solution. The first thing, it has a lesser purity than the primary standard. Usually, what the standard solution you choose for this well, for preparing a secondary standard solution, it is always less pure compared to primary standard solution. And even it is less, it's entirely different, reverse from the first primary, less stable and more reactive than primary standard solution, less stable, more reactive, and but its solution remains stable for a longer time. It should be stable for a longer time than titrated against primary standard solution. I already discussed about the calcium carbonate. The preparation, the calcium carbonate, what we consider primary standard solution. Using that we'll standardize the EDTA solution. So that EDTA is a act as a secondary standard solution. That secondary standard solution usually titrated against primary standard solution to standardize the secondary standard solution. Okay, so these are the main properties observed under secondary standard solution. Less purity than primary standard solution, less stable and more reactive than primary, but it is stable for a longer period and titrated against a primary standard solution. Usually a chemical fit for being a standard chemical and does not meet the requirements of primary standard. The best example is anhydrous sodium hydroxide. Primary, this is a secondary standard solution. It is extremely hygroscopic in nature. As soon as if you open that container, it will absorb moisture from the atmosphere. Within no time, it becomes moist one. Okay, that is sodium hydroxide. That becomes anhydrous. So the primary standard, so it cannot be used as a primary standard solution because it is a hygroscopic in nature. It immediately absorbs water and even small quantity of carbon dioxide from the atmosphere. The actual composition, that is sodium hydroxide, it becomes other than sodium hydroxide. Other than sodium hydroxide means sodium hydroxide containing few moles of water. Another is a potassium permanganate. So I already discussed this one. So this potassium dichromate is usually used as a oxidizing agent, but potassium permanganate, even it is an oxidizing agent, we normally use a freshly prepared potassium permanganate. If you are want to detect the strength of or any for any purpose, if you want to use potassium permanganate, it should be freshly prepared because it is used as a secondary standard. It is a good oxidizing agent, and in other words, it is very reactive and less stable. It is a more reactive, that's why it oxidized, forming manganese oxide. Okay, instead of retaining it as a permanganate, it converted into manganese oxide. That's why it is unsuitable for using as a primary standard. But potassium dichromate is used as a primary standard. Okay. Similarly, sodium thiosulfate, it also absorbs carbon dioxide and it get decomposed. Okay. So these are some few examples for secondary standard solution.